Hi students, welcome to my lectures on chemical engineering thermodynamics. I request you all to follow from the beginning of my lectures because every lecture is connected. Today we are going to discuss about finding of bubble point pressure. Okay, there is a mixture of A and B. Today we are going to discuss about the binary mixtures. Suppose there are two components are present in the liquid mixture. Let us say we have started heating. Okay, at one point of time the vaporization starts. That means the bubble starts appearing. At that point of, at what pressure this bubble, gas bubble or vapor bubble going to form, and what is the composition of A and B in that particular bubble. That means you have a liquid. If you start bubbling it, vaporizing it, and during that point bubbles will form. At the first bubble, what is the composition of vapor and a liquid? That is what the today's example. Suppose there is a container consisting of liquid of A and B. Okay, the liquid composition is given. Suppose the component A is 0.2 20%, that means and the component B is 80% in this liquid mixture. We have to find out at what pressure this bubble is going to form, but inside the bubble what is the YA composition, what is YB composition, fraction of A in the vapor and fraction of B in the vapor. Given temperature equal to 75 degrees centigrade, everything happening at a temperature of 75 degrees centigrade. So let us see what happens. Let us find P, YA and YB. P is the pressure at which the bubble is going to form, that's called the bubble point pressure. Given what will be the given temperature will be given, XA, XB will be given, and the second is find P, YA, YB. This is what the calculations we are supposed to do while finding out the bubble points. Let us say that acetonitrile and nitromethane are there in this liquid. Acetonitrile having 20% in this liquid, which is denoted by A. Nitromethane is 80%, which is denoted by B in this mixture. That means XA, XB are provided. The A, B, C, if you know Antoine equation constants, to find out saturation pressures, saturation temperatures of pure acetonitrile and pure nitromethane. To find out the saturation temperatures and saturation pressures, you should use Antoine equations. In that Antoine equations, you require A, B, C values of the equation. So acetonitrile A is 14.2, B is this much, and C, the constant is this much. The A, B, C constants of nitromethane is also provided. In this example, the temperature is constant. That means while calculating different things, you need to fix the temperature first. So temperature is 75 degrees, that means 348.15 Kelvin, which is equal to the saturation temperature of A, because A and A are existing at the same temperatures. So saturation pressure of A is also 348 and saturation pressure of B is also 348. The pressure will change because saturation pressures and temperatures depends on the corresponding values. If you change the temperature, pressure will change. If you change the pressure, temperature will change. At this temperature, which is designated at 75 degrees centigrade, PA sat and PB sat can be calculated using Antoine equations using A, B, C constants which were given provided. So these are the bubble point pressure calculations now starts. And if many books, people will denote the symbol. Example, for more volatile component, people will designate the number 1 for a binary systems, and for the low volatile component, it will be denoted by the number 2. So if you follow any books, you are going to see not with respect to A and B, with respect to 1 and 2. 1 is denoting the one which is having highly volatile, the 2 is given to the component which is having low volatile. So let us see among this acetonitrile and nitromethane which one is high volatile and which one is low volatile. So if you put the temperatures in the Antoine equations, Okay, saturation pressure of A, that means acetonitrile, is 83.21. Saturation pressure of nitromethane, you get 41.98. Among these two, which one is high volatile? At 75 degrees, because we have calculated the saturation pressures at a temperature of 75 degrees centigrade, because at the fixed temperature, the one which is giving highest pressure, that is called a highly volatile. The one which giving low pressure, that is low volatile. So among the A and B, acetonitrile is having highest pressure, that is why it is given by symbol 1. Among the 41.98, which is low pressure, which is given nitromethane, symbol 2. So they, from now onwards, I mean to say that from in this example, we are going to follow not with respect to A and B, with respect to 1 and 2. 1 is acetonitrile, 2 is nitromethane. So X1, Y1 is representing the liquid composition and vapor composition of acetonitrile. X2, Y2 is liquid and vapor composition of nitromethane. P1 is nothing but PA sat, P2 sat is nothing but PB sat. So let us apply the Raoult's law, because we have to find out what is the total pressure, bubble point pressure, and YA and YB. These three things I am supposed to calculate. If I apply the Raoult's law for component 1, which is acetonitrile, Y1 into P is equal to X1 into P1 sat is equal to partial pressure P1. Y2 into P is equal to X2 into P2 sat, which is nothing but partial pressure 2. You know the total pressure is sum of the two partial pressures 1 and 2. So from these equation, substitute the P1 value and P2 value in this equation, so that you get P equal to X1 into P1 sat plus X2 into P2 sat. I know because this is a binary system, X1 plus X2 equal to 1, Y1 plus Y2 equal to 1. So replace this X2 with 1 minus X1. So you get a final equation, P equal to P2 sat plus P1 sat minus P2 sat into X1. This is the equation you are supposed to use to calculate the bubble point pressure. And you know everything. You know P2 sat, you know P1 sat, you know X1. X1 is X1 in the sense here our X1 is nothing but XA, which is 20%, and X2 it is given by XB, which is called 80%. Everything is given in this equation. You are supposed to calculate what is the total P. The total P is 50.23. You can see now you have calculated what is the bubble point pressure of liquid which contains 20% of acetonitrile and 80% of nitromethane. The bubble will start at that particular pressure. So the bubble has started. In that bubble, vapor will be there. How much amount of acetonitrile and how much amount of nitromethane will be there? So let us calculate. Using Raoult's law, Y1 equal to X1 into P1 sat by P, Y2 equal to X2 into P2 sat by P. I know X1, I know P1 sat, I know P, because we have calculated what is the bubble point pressure. Similarly, X2 I know, P2 saturated I know, P I know. That means Y1 is 0.33, Y2 0.67. You can see if I have a 20% of acetonitrile, 80% of nitromethane, if I start vaporizing it, what happens? Now in the vapor, it is 33% acetonitrile is there, 67% nitromethane is there. You can see the purification has happened. In liquid it is 20%, in vapor it is 33%. So this is why we have to apply vapor liquid equilibrium concept in purification and separation process. Now you can understand that why we are partially vaporizing it. If you completely vaporize it, there is no point of separation. You have to partially vaporize it. At every point of time, liquid and vapor phase should coexist. Otherwise, what happened if you vaporize everything? In liquid also it is 20%. If you completely vaporize it, in vaporize also it is 20%. That is what there is no point of completely vaporizing the things. So you always have to partially vaporize. If you wanted to partially vaporize, you should know what should be the temperature and what should be the pressure. Okay, that means if you keep 75 degrees centigrade, in the container and pressure which is 50.23, then you can see the separation of 20% to 33%. Once vapor comes, you can simply remove the vapor and condense it. Automatically you get a purified acetonitrile. Okay, that is how you have to apply the Rolle's law for the case of finding the pressures and temperatures for your targeted separation. Okay, here you can see in the liquid I have 20% acetonitrile and 80% nitromethane. That means for these liquid compositions I have a pressure of 50.23. What happens if I change the liquid compositions? Example, XA, acetonitrile, if I take 40%, nitromethane it is 60%, and what happens? Of course, the pressure, the bubble pressure will change depending upon the what composition of liquid you are going to take. So same procedure you have to apply, okay, because I have done the sample calculations of 20% and 80%, and you can redo the calculations for 40%, 50%, 60%. Like that you can change the liquid compositions and see what are the pressures you are going to get, because every pressure, every composition there will be different pressure, okay, because if you take the pure component, if you take pure acetonitrile and pure nitromethane, always you can see at same temperature vaporization, condensation happens, just like a water. If you take a water will evaporate at 100 degrees centigrade, and water can also condense at 100 degrees centigrade. That means vaporizations and condensation process can take place at single temperatures and pressure. Whereas if you mix two liquids in a container, so vaporization and condensation point will be different. Okay, that is what we are going to see. Okay, so what is the what I mean to say is, what is the temperatures and pressure for the bubble point? If you keep the temperature at 75 degrees centigrade and pressure of 50.23 in this container, then the bubble starts forming. If the bubble starts forming, then in the vapor 33% acetonitrile and 67% nitromethane. So you can see I have done the calculation for this. Simply you can do the calculations for the other composition. Let us say if x1 equal to 0.4, x2 equal to 0.6, 0.6 and 0.4, 80 and 20, you can recalculate and you can find the bubble point pressures will change. And for 40% you get 58, for 60% of acetonitrile you get 66, for 80% 74. And the top corners, that is pure one. That means x1 equal to 0, x2 equal to 1 means it's a pure. What is x2 equal to 1? In our case, number 2 is given to the nitromethane. So x2 equal to 1 means pure nitromethane. What is the bubble point of pure nitromethane? 41.98 you have calculated here. Saturation pressures and saturation temperatures defined for the pure components. So at that 41.98 is for the pure nitromethane. X1 equal to 1, x2 equal to 0 means it is for the pure acetonitrile. Okay, acetonitrile, and you can see bubble point 83.21, which is already calculated. The corners, the first one and last one of this is for the pure components, and in between these there is mixtures. This is solved. Rest everything, I mean to say that you can do the homework, the other three. So let us plot based on the data generated for different liquid compositions, what are the vapor compositions I get. For the if I plot PXY graph, okay, on the y-axis I plot the bubble point pressures, on the x-axis I plot x1 or y1, because always you have to plot on the x-axis, you have to take high volatile component fractions. Either you can plot x1, y1. x1, y1 denotes the liquid and vapor compositions of acetonitrile. Okay, so let us plot px1 on first once, and next you plot p and y1. Okay, if you plot p and x1, you get this blue curve. Okay, if you plot p and y1 you get red curve. Okay. Imagine whatever we have done today, I have plotted on the, I will explain you on the graph. Here what it is saying, at this 50.23 pressure, liquid acetonitrile is 20% and vapor is 33%. Let us plot. At 50 you have to map this 20 and 33. That means let us plot a horizontal line at 50. Okay, you can see what is this blue one? This is called x1. Okay, x1 it is called 20%. That's why it's called touching at 20%. Okay, this is the 20%. At the same 50, what is the y1? You have calculated it is 33%. That means at a 50 bubble point pressure, the liquid will be 20%, vapor will be 33%. The line connecting these two, it's called tie line. That means at this particular pressure, liquid will having 20%, vapor will be having 33%. That is why at this constant pressure, you have the x1 here, y1 here. Similarly, if you do it for the other compositions, let us say 40%, the bubble point pressure is 58. That means at 40%, the bubble point pressure is 58. Okay, at 58, okay, at 40%, the bubble point is 58, and what is y? It is 0.56. Okay, this is around 0.56. That means at this 58 pressure, the x1 will be 40%, y1 will be 0.56%. That is why at this particular pressure, x1 will be this 40%, y1 will be, okay, like this. x1 will 40%, y1 is 0.56. You can see at every pressure, I can connect the things. At this particular pressure, the x1 will be this and y1 will be this. So at every pressure, if I am joining these two x1 and y1, blue curve and red curve, the line, every line is connecting the blue curve and red curve, every horizontal line, it's called the tie line. Okay. On the extreme, this is 0%, x1 equal to 0, y1 equal to 0. And here x1 equal to 1, y1 equal to 1. On this axis, I can plot either x1 or y1, I mean both. x1, if I plot p versus x1, I get a blue curve. If I plot p and y1, I get a red curve. Okay. If x1 equal to 0, that means left hand side, it is pure nitromethane, because here x1 equal to 0 means what happens to x2? x2 equal to 1. That means the point here, the 41.98 denoting pure nitromethane. On the right extreme side of the graph, x1 equal to 1 means x2 equal to 0. What is x1 equal to 1? 100%. Okay. x1 is denoting for acetonitrile. That means the pressure here 83.21 is for the pure acetonitrile. This is for the pure nitromethane, this point. And you can observe the every other point is lies between the pure acetonitrile and pure nitromethane. You can see the bounds for this graph is this pure nitromethane and pure acetonitrile. On top side of this will be liquid, because at high pressures there will be liquid, low pressures there will be vapor. So on this, above this blue curve, everything will be liquid, and below this red curve, everything will be in vapor state. What happens in between? Between this eye, you can see it's a kind of a eye. Liquid and vapor both exist between these two locations. That means you always have to maintain pressure between these two lines, then only liquid and vapor both exist. If you go for very high pressures, entire thing is liquid. If you come below this, entire thing will be vapor. So if it is entire liquid, entire vapor, then there is no separation. Always liquid and vapor existing between the blue line and red line. So that is why if you want to separate, keep the pressure, example, keep pressure always between these two lines, then only liquid plus vapor exist. Okay, this is called, okay, P, this is called Px curve, this is called Py curve. Okay, if I use the blue color, this talks about Px curve, this red curve, it's a Py curve. And the other point, the other thing, name for this Px curve is the bubble point curve. Okay, bubble point curve. The red line, it's a dew point curve. Okay, we will discuss how to find out the dew points also. I hope now you understand the importance of this particular graph. Okay, let us meet with another lecture finding out dew point pressure. Just like we have found the bubble point pressure, we will find the dew point pressure. See you.